cool. Okay, so this is part A of the assessment, so you guys know what you're looking at. Remember that the titration assessment has 4 parts, and what we're going to do is teach the first part, assess it, teach the second part, assess it, teach the third part, assess it, teach the fourth part, assess it. So that way we're assessing it while it's still fresh in your head. Part A is all about trying to figure out a dilution for the titration. So before you do the titration, how much do we need to dilute one of our samples by, so that way I have nice values, and why I would need to do that as well. So this is the instructions that you're going to be given. So basically it just talks about how you're doing a quantitative analysis and you're trying to figure out the concentration, in this case, of lactic acid in sour cream. So in each one of these different assessments, you're going to have a slightly different acid and a slightly different household substance that you're testing. The other thing you're going to find in these is that we are going to give you guys information about what is the expected range of what you should see with the lactic acid. So lactic acid you should find in sour cream at about 0.55%. That is what the manufacturer is claiming, and we are trying to verify if that's correct. However, during the purifying process, the concentration increases to somewhere around 11%. So when you guys are doing your calculations, we should be able to double check, is the lactic acid concentration in that undiluted purified sample at 11%. Are we okay with that so far? All right, cool. So first thing we need to do is develop our protocol. So this is the equation of the neutralization that you guys saw in your beaker. So I had this here, which is my lactic acid, and I added that sodium hydroxide, and then I have a neutralization reaction. So we've given you that equation. You don't need to worry about having any of the equations. When this ratio is equal, it will be neutralized, and that's why we're using the indicator to help us figure out when is that ratio balanced. Are we okay so far? All right, so they give us information about the equipment. We're going to hold off in reading that because I want us to start looking at the document and how we fill this in. So first thing that you are doing is just making a note of what you noticed as the ratio. So what was the estimated neutralization ratio between the unknown, undiluted, and it shouldn't say vinegar, it should say sour cream, with the 0.1 mole per liter of sodium hydroxide? Again, I see another typo. That should say sour cream. So we'll fix that. All right, so how many mils of sour cream did we add? Just the 1 mil. And then you guys added the sodium hydroxide. We had a range of 11 to 16. That is fine. That is okay, because this data is not supposed to look good. Whatever number you get is the number I want you to use for your calculations. Now, since I want us to all have the same calculations for our notes, I'm going to use the average, and the average from our class was roughly 14 milliliters. So basically with that, what that tells me is for every 1 milliliter of sour cream, I would need 14 milliliters of sodium hydroxide to neutralize that. So if I was trying to do a titration, and if I was trying to do that titration with the smallest pipette I have, which is 10 mils, how much sodium hydroxide would I need in my burette, in theory? So if I had, in theory, if I had 10 milliliters of my sour cream, how much sodium hydroxide would I need to neutralize that? 140. My burette only goes up to 50. Also, that is buckets and buckets of solution that I shouldn't need to use. So what that tells me is that I need to dilute that sour cream. So it needs to be diluted. Are we okay with that so far? All right, so the next thing I then need to figure out is how can I dilute it? What are my options? So when we're planning this method, we need to see what we have equipment-wise. We need to see what pipettes we have. We need to see what volumetric flask we have, and then we need to do some calculations to figure out what is the possible dilution factors and what are the possible titrate volumes. So now we go back to our method and do some reading to see what pipettes we've been given and what volumetric flasks we've been given. So it says down here that I have been given a 10 mil and a 25 milliliter pipette. So remember with the pipettes, we are talking about these things, like the little glass ones that you were using as your aliquots. So I have a 10 mil and I have a 25 mil. Those are the two that I told you I'm providing. The other thing that I see in that is that it tells me you are also given a volumetric flask at 100 and 125. It's like 225. Oh, this is 1,000. That's too big. All right, this is an example of a volumetric flask. These volumetrics, yeah.
You said 225.
Sorry, 100 and 250. Yeah, sorry. I misread numbers all the time. So those are the two sizes that I am given. This is an example of what a volumetric flask looks like. It is just like our other flasks, but the thing that's different is that it's more curved. And instead of having labels on the side saying 20, 40, 60, 80, 100, it doesn't have any of that. It just has the one line. And that one line is what's being filled up to, and that's going to be, in this case, 1,000 milliliters, so 1 liter. Are you okay with that so far? So it's just like the pipette with that one line to accurately measure that one volume. So in this case, I've been given two different ones, 100 and 250. Are you okay with that so far? All right, so if we go back to our sheet, let's write down our options. So option number 1 for my pipettes were 10 milliliters and 25 milliliters. And then for the volumetric flask, I've been given 100 milliliters and 250 milliliters. Are we okay with that so far?
Yes.
I heard a no. Not yet. All right, can I start explaining dilution factors?
Yes.
Okay. So what you need to do is think about the combination of pipette and volumetric flask. I'll draw a little picture to help us visualize what we're doing. You don't need to draw a picture on the assessment. It's just to help kind of think about it. But what you do, say for example, is I have a 100 milliliter flask and I have a pipette like that, and that one's 10 milliliters. So that 10 milliliters goes into the volumetric flask, and then I fill the rest of that volumetric flask with water. So it is 10 into 100, and if I was to simplify that ratio, what am I diluting it by? 1 to 10. So that's a 10-fold dilution. All right. What are my other options? Well, I could also go, let's do 25 into 100. So if I did a 25 into 100, what's the dilution? 1 to 4. So that would be a 4-fold dilution. All right, if I did, let's do back to the 10 into 250. What dilution factor is that? 1 to 25. Are you guys seeing how we're getting these numbers? So that's a 25-fold dilution. And then my last option is 25 into 250. So that is a 1 to 10 dilution again. So I have two options for my 10-fold, don't I? And that's useful to me. Are you okay with that so far?
Yes.
Thank you. Bro was like, someone's responding. Okay. Cool. So let's talk about the calculation. So I want to calculate if I diluted my stock, how much would the titrate volume be? So how much would I need of the sodium hydroxide from the burette? And I want to hit a certain range. I want to ideally have my titrate volume be between 10 and 25 milliliters. And I'll explain why in a moment. So here's how you do that calculation. My titrate volume, so what's coming out of the burette, is going to be equal to the aliquot volume. The aliquot volume is what's coming out of the pipette. Times your desired dilution versus your actual dilution ratio. So when we say desired one, these are the desired dilutions. And then the ones, this here is your actual. Are we okay with that so far? I might zoom out so you guys can see the whole thing. Are we good? Keep going? Give you a second. All right, keep going? Okay. So what you should then do is set up a table so that way you can see what all your options are, because that way you can select which one you want as your method. So for this table, what I have on the left-hand side is I want to list out my different dilution factors that I could potentially use. So we have the 4-fold as one option. We have the 10-fold. And we have the 25-fold. So that's the first thing that I have for my table. So these are your desired dilutions. Your desired ratios. Are we good so far? All right, ratios. All right, keep going. Give you a second. All right, keep going. All right. On the top here, as our other factor, is going to be our aliquot volume from the pipette. So we had two different sized pipettes. We have the 10 milliliter pipette, and we have the 25 milliliter pipette. So this is basically what we're looking at is the diluted solution. How much do we use for the titration? And I'm writing down extra notes just so that way you guys understand what the different things are. Obviously, you won't need to have all the extra little bits like the equation and this bit here. It's just so you know what's what. Are we okay so far? Okay. It's being recorded, so you can still watch it. All right. So the next thing I then need to do is some math. You're going to need to use a calculator, obviously, on this assessment. Can you guys see the calculator okay if I punch in some numbers? You can if you want. I'm just doing it on the screen. All right. So let's do this math calculation. So for the first one here, I'm doing an aliquot of 10 from the pipette of the diluted solution. It's really important that you have everything in parentheses, so that way it does the order of operations correctly. So my first thing that I have is my desired dilution. So I'm going to first test out the 1 and 4. And then I'm going to divide it by the actual ratio. So my actual ratio was 1 to 14 when we did the experiment. Are we good so far? And then I close bracket, and that's my calculation. So what that tells me is that if I did a 4-fold dilution of my stock and used a 10 ml pipette, I would need 35 milliliters from my burette. So the numbers inside this box here is going to be the estimated titrate volume during titration. Are we okay with that so far? Do you want me to plug in some more numbers to show you, or you guys want to do those calculations and have a little break from me talking? What is that? You want to practice it, or you want me to do another one? Another one? Okay. So what I find with my calculator to make my life easy, I can do and copy that same equation. This time I'm going to do the 4-fold, but I'm going to test it with 25 milliliters as my aliquot. So I'm going to change this 10 to a 25, and what that tells me is that it's 87.5 milliliters for the titrate volume. That's going to be a lot still. It's better than what it was before, because before it would have been 140 milliliters, but this is not a good enough dilution to get where I want. We good so far? Yeah. All right. So I'm going to again change the ratios. I'm going to retype it in actually. So again, we're using a 10 milliliter pipette. In this case, we're going to do a 10-fold dilution, so 1 into 10, and divide it by my actual, which is the 1 and 14, and then close bracket it all. So if I had done a 10-fold dilution and did a 10 milliliter aliquot from the 10-fold dilution, in theory, I should need 14 milliliters of my, oh, you turned off, of my titrate, of my base. Does that make sense? All right, I can do that again. Instead, swap it out for 25, and I would need 35 milliliters. You ready for the last one? Looking at my options. So we'll go and do again the 10. In this case, we're looking at the 25-fold dilution. If I did that, I would need 5.6 milliliters. And if I was doing that for the 25, I would need 14 milliliters. So those are my options. Cool. All right. Now, which one should you select? We want to make sure our titrate volume is between 10 to 25 milliliters. That is the ideal range for our titrate.
10-fold.
So I can do a 10-fold. This one's fine. These two are too big. That one's too big. That one's too small. That one's fine. So you have two options. Either of those options will be fine. I will mark you correct for either of those two. Okay? So then we have a proposed procedure that you guys need to fill in to explain your method, and I'll walk you guys through it. I'm going to take the 10-fold because I think the 10-fold is the easiest one to do. With the 10-fold, I actually have two options. I could either make a 10-fold in 100 milliliters, or I can do a 10-fold with a 25 into 250. So it doesn't matter which one you choose. The original solution of household vinegar needs to be, or sorry, not household vinegar, household sour cream needs to be diluted 10 times. And the sample that I'm going to take from the diluted solution is going to be 10 milliliters. So basically I'm saying we're diluting it 10-fold, and I'm taking a 10 milliliter dilution from there, or sorry, 10 milliliter aliquot from there. So that's how the numbers translate into that paragraph. This will require dilution by achieving by pipetting, and now you need to explain how you're diluting it. You can dilute it two ways. You can either say you're diluting 10 into 100, or you can say you're diluting 25 into 250, because both of those result in a 10-fold dilution. Either or I would be happy with. I'm going to just go with 10 milliliters of the original solution, adding distilled water to make it up to a mark of 100 on a volumetric flask. So that paragraph explains how you dilute it. All right, in the actual titration with the sodium hydroxide, I will use again, you repeat the number you have here, down here, a 10 milliliter pipette to deliver the aliquot of the diluted household. I didn't change it. Sour cream. I'm going to fix this for next year. Into a flask, add a few drops of the phenol, titrate to the standard sodium hydroxide. The color will change from clear. We don't use the word white. We use the word clear. We use the word colorless. To pink. And then I would predict the average titrate volume to be approximately 14 milliliters. And that's how we fill in that. All right, any questions? Ruben? 1:30. Yeah, sorry. I know we've had two very heavy theory lessons. But tomorrow I'll let you guys have it as a study to practice. All right, keep going. Okay, so let me explain to you guys some of the achieved merit and excellence requirements. I should have probably color-coded it from the beginning, but that's my bad. So for the achieved, what I need to see is a method. This here is your method. And you're allowed to make mistakes in this method. So maybe the dilution that you suggested was a bad dilution. Maybe you suggested the fourfold dilution. The other thing is that you have a correct dilution. So the dilution you selected makes sense, but you have an error in your calculations. That would mark you down to an achieved. A merit level student will have the correct plan, but they might have made a mistake when it came to what they selected. So a merit level student for their range, for example, might suggest something that's between 8 and 30 milliliters. So you've gone a little bit too low or you've gone a little bit too high. It's a really stupid reason to get a merit. You want to have that 10 to 25 range. The other thing you need to do is justify why you are doing the dilution and why your method works. So that is on the next sheet over here, the explanation. So I just want to kind of bullet point some reasons for your justification and what I'm looking for. The main thing, first off, and this is the things that, like I said, is what I'm looking for, the merit and excellence level, is I need you to talk about your initial ratio and why you need to dilute. So in this case, when we looked at the original ratio, it was 1 to 14. And if I did that in an actual titration, I would have 10 milliliters to 140 milliliters. So that's not okay for my dilution. From that information, I then will talk about the range that I would want for my titrate. So the titrate is too large. 140 is too large for a titrate volume. The titrate volume should be between 10 to 25 milliliters. Are we good so far? So the next question is, why do I say 10 to 25? When I say 10, we are talking about the lower limit. So with that lower limit, we need to be mindful that the error in the burette is about 2%. So if I have a 10 mil sample, so 0.2 is what I have as the error, 0.2 mils. If my titrate volume was 10, and I times that by 100, I would have 2% error in my titrate. Ruben.
Let's say 10 to 25 milliliters.
Yeah, milliliters. So that is what we're thinking. In my example, so tie it back to your method. What was our titrate volume going to be? 14, remember? How we did the math in the box? So 14 milliliters is what I would have as my titrate. What's my percent error then? If I do 0.2 divided by 14 times 100, my error then is going to be 1.43. So that's pretty good. The higher my titrate volume, the smaller that error becomes. So if I had it into 25, 0.2 divided by 25 times 100, I would have a 0.8% error. Are we okay with that so far?
Yep.
Cool. All right. The next one here then is my upper limit. This one was more obvious because you guys saw that one yesterday. With the upper limit, I don't want to go above 25 because first off, we waste reagent. The second reason is because we would need to refill the burette, or we can't get multiple, refill the burette more often. So in theory, if I have a 50 milliliter burette and I have a 25 milliliter titrate, I can do 2 titrations from that one filling. Does that make sense? If I have 30, then I'm going to have to refill it. And if I'm above 50, then I have a real big problem. So that's what we're looking at as our second kind of thing. Why do we have a lower limit? Why do we have an upper limit? What have you decide? The other thing you can think about is the volume of diluted solution you made. So if I made 100 mils and my aliquot was only 10 mils, how many titrations can I do? 10.
Yes.
Is that good? Because then I can do lots of repeats. If I did 250 and I only had 10 mils as my dilution factor, I would have 25 titrations. Now, where I'm pulling this number is, remember how I said with the tenfold dilution you had 2 options? You can either make 100 mils or you can make 250. That's where I'm getting that number from. So I'm just trying to explain how many times I can repeat that experiment. So that's talking about the total diluted solution. And this is talking about the aliquot. So just to help me justify what I'm doing and why I'm doing it. So we want to be able to repeat the experiment so that way we can have reliability in those results. Ruben.
What does it say after explain?
Explain volume. Yeah, explain volume titrated. Or sorry, explain volume, I actually say diluted solution. Does that make sense? So for the excellence, I really need to see that you're tying it back to your method and how your method allows for increase, not increase, how your method explains why you've diluted it and why your dilution works. If you're a merit level student, you would just be able to give me the general, what's an upper limit, what's a lower limit. Does that make sense? So merit level student will only give me an explanation of why you dilute. An excellence level student will be able to tie it back specifically to their experiment. Do you want me to write that down, or are you guys okay? Yeah,
Yes,
Ruben.
if I can introduce on your website, right?
Yeah, yeah. So you're always welcome to rewatch this. That's what you got to do for part A. Any questions? Nope. All right. So tomorrow, what I'll do is I'll pass out the homework questions. So it's basically you got let me find it. You have a packet of questions. The first chunk of it is all example questions that are exactly set up the same way, so you can practice it. And I think I give you the ratio of acid to base, so that way you know what you're working with. And then there's more problems at the back as well. There's a whole page if you want that. So the trick to this is lots and lots of practice. Tomorrow I'll give you guys a session just to do as a tutorial. Do you guys want to do it practically, or do you just want to sit and do some math tomorrow, if you understand math? Sorry? Wait until tomorrow. It's not hard for you to set up the experiment. Yeah, got that.
Is this for when we do actually this?
So this is practice questions, and it's the exact same setup as what the internal is going to be. So it's just the same model of these questions.
Oh, okay. So it's like homework?
Yeah. So the homework is question 1 and 2. You can all just shaking hand and for each other. But I'll give you guys class time tomorrow as well to work on practicing this. And you can do it practically or you can do it on theory, because the experiment isn't that hard on this scale. It's just pipetting into a beaker. And it doesn't even need to be accurate. The main thing I'm worried about is can you write it up. Alright, cool. That's everything for today. Make sure you spray, wipe down the tables. And have biology next, so you don't have to worry about putting up the chairs.